Good afternoon. Welcome to our webinar for Mass Notification Emergency Communication. We're going to look at the past, present, and future of the products and of what mass notification is. We're going to look at the wide area network coverage and how we can integrate this and what we need to do for integration to make sure it's a mass notification and emergency communication system. If we think about mass notification, it's not a new concept. It's been with humanity from the beginning of communications, and people down through the ages have put up warning signs and also posted danger messages. But what has changed is who we communicate to, the size of the target audience, and also the way we deliver the message, the methods. Today's presentation will look at the evolving nature of mass notification and how it's going to impact us in Canada, especially going forward, what equipment we're going to need, what things we're going to address. So we're going to look at the history of the codes leading to the mass notification standard and what defines emergency communication systems and the future requirements and specific equipment for the public address system. And we'll look at TOA's products that we bring to the table of how we meet the challenges. And of course, we're all concerned about how it's going to affect our industry moving forward. Looking at the beginning, it is a standard that's been around, and if you think about on the lower right-hand corner of the screen, you see a stone there, and you could probably think of this as carved in stone. Well, it was at that time. This was a message put on the high water mark for tsunami areas, and it warned people, do not build beyond this point. Now, people had the choice of listening to those messages or ignoring them. Unfortunately, many ignore the messages, and we see what has happened in the recent tsunami in Japan. But coming a little bit closer to home, we think about our building codes and the requirements that are outlined for structures, etc. We look at the historical nature of mass notification. Think of 1993 and the NFPA 72. It is really designed to minimize risk, and risk to life, risk to property. The military really came up with a standard called the Unified Facility Criteria. And this is designed to unify the requirements for all of the messaging, and it took into consideration things like fire alarm signaling, visual strobes, and many other things like that. Voice commands that rely strictly on fire signaling are low fidelity, sometimes not articulate enough, and not understandable. So speech intelligibility was analyzed as being required for a mass notification system. And the codes that have been arrived at, although they are codes, they are not hard and fast, carved in stone standards, because they are subject to the authority having jurisdiction, or the AHJ as is used in the code. They have the final say, and they can set the guidelines of what standards and what part of the code is going to be applied. So where did we come from? Well, we think back to 1996, Khobar Towers in Saudi Arabia, and how there was a realization after that there was a need for a standard to notify people. So the Unified Facility Criteria standards were developed, and before that there was no plan to minimize those casualties. So they learned a lot. They put these into practice in military establishments. But then look at what happened in the civilian side. We had events such as what happened in Montreal in 1989, Oklahoma City in 1995, and then the shootings at Columbine High School in 99, and then of course in 9/11 event in New York City. It brought it all home as being something that can affect each and every one of us. And so Homeland Security was created that set about analyzing things and putting into practice things that have to do with protecting the public in general. Then we continue to have events such as Dawson College, Virginia Tech, and even right here at home in Canada, in Ottawa, 2014. And from each of these events, they learned certain things. For example, what was learned in Ottawa in 2014 was that when an event happens that's suspected of being a terrorist activity, they usually collapse the cell towers. They shut down the signal, and so messaging cannot get out by cell phones using current technology that's available from the cell phone providers. Well, they did learn that there is a need for sending messages, and so they are working around that, coming up with new messaging and making it available so that people can receive messages on their cell phones. That's not implemented yet, but that's up to the cell providers to put that into practice. But then we come down to the standards that are current for Canada. We have ULC S57614. That was adopted September 2014, and it's a standard outline for what is required for an emergency communication system in Canada going forward. Basically, it outlines the purpose. It's for the protection of life by indicating the existence of an emergency, and it's intended to communicate that information to respondents. Emergency communication systems are intended to provide the information for different types of emergency situations. Prior to this, the most important was the fire, but you and I know that when our kids were in school, they had fire drills. Well, when we were in school, they had fire drills, but now our children, when they're in school, they have lockdown drills. So it's not just fire anymore. And so they understand that human-caused events, whether they're accidental or intentional or other situations, call for specific messages to be given. And that's also the case in the event of natural disaster. So it's what we need to do in order to be compliant with the needs. We can refer to NFPA 101, and it's a life safety code. It's the most widely used for protecting people in buildings and the occupancy. And we look at NFPA 72. It provides the latest safety provisions that meets society's changing needs. And it deals with fire detection, signaling, and emergency communication demands. And it also encompasses other things, such as weather emergencies, terrorist events, biological events, or chemical or even nuclear events that need to be made aware to people of what's going on. So basically, this code doesn't define the equipment as much as it does of how you meet the standard. And it doesn't replace any of the other codes. It doesn't replace the building code, doesn't replace all the government regulations such as CSA or life safety codes such as the UL and ULC standards. It doesn't replace the fire code or the electrical code, but it references all of these codes so that we can understand that this is intended to bring all those codes together for an emergency communication or mass notification system. And the purpose, of course, is at the end of the day to save lives, to protect property, and provide for the continuity of commerce. So the application could be in any of these events and situations. It could be civilian, could be military, could be corporate, could be health-related. So a system needs to be operational. We mentioned the authority having jurisdiction. Who is that? Well, it's an organization. It could be an individual, or it could be a body such as a government office, and they have the responsibility to enforce the requirements of the code and to specify what equipment and how the equipment operates. And that term, AHJ, for authority having jurisdiction, is encompassed in this standard. And basically what it says, where public safety is primary, the AHJ may be a federal, state, local, or other regional department. It could be a labor department, could be a Department of Health, or could even be right down to the electrical inspector. And interestingly, it also states, for insurance purpose, an insurance inspection department or rating bureau or other insurance company representative may be the authority having jurisdiction. So at the end of the day, the facility, you need insurance for it, and sometimes you need it to be certified to have occupation permission. And at the end of the day, someone might say you can or you cannot based on whether you have or do not have a mass notifications system. And so insurance companies could start to ask for this. Now, is that unusual? Well, not really. In Ontario, for example, effective today, April the 15th, standard has been changed for even residences. We must have a carbon monoxide detection device on each floor where there are bedrooms and on each floor for residents. So standards are dictated, and sometime in the future, maybe someone will mandate that this be standard across the board. So what are the requirements? Well, it's a local or a global solution. What that means is that we can provide information locally or can provide it outside of a given area. And it must alert occupants of the emergency situation, and not just some of the occupants, all of the occupants. Must provide timely information. What is happening? Is it escalating? Are we just checking it out? Is it under control? And so there must be timely information. Wide area notification is required as well. Think about the situation of a school in a lockdown situation, and you have school buses coming delivering the children. You have to have a means of letting those school bus drivers know, do not bring the children to school. Go to another area. Can use live or pre-recorded messages, so they can be stored, and pre-recorded messages have the advantage of being able to be recorded when you're not expressing emotion, and so the messages can be clearer. You also have the assurance of knowing that you're saying the right thing under the right situation. It must have the ability to operate in more than one location and must interface with a wide area system. There must also be a verification system, monitoring of key components in the system and able to poll results to see what was said, what events happened, how they were responded to. There should also be redundancy, and this is outlined of what type of redundancy and what communication paths, and even redundancy of the power that provides power for these systems. Now, it also addresses what components can be used. Can incorporate the telephone connection for using the telephone system, strobes, access to cell phones or devices such as radios, pop-up text, audio message, reader boards, and then even for outside areas, a high-power speaker array to make sure that everyone in the area gets the message. So basically, we're looking at inside a facility for things like the intercom, the video, the fire panel, pop-ups on computers, phones in offices, etc. Outside, we look at high-power speaker arrays, paging horns, video screens or sirens to be able to let people know that there is an event. And then at your side, which refers to our personal devices, cell phones, radios, emails, etc. So all of that can be encompassed into the mass notification system. And so that's what's embodied in the ULC S57614. But just a little bit more clarification on it. The most significant change that we noticed from the past standards and the past way of looking at things is that fire is not the only risk. Signaling must indicate other events, not just fire. Could be tornadoes, earthquakes, terrorist activity, etc. And it must be able to communicate specific information. It includes mass notification as a chapter in the code, not just an annex. What basically that means is that if it's an appendix to a document, it's more or less a good to know thing. But being a chapter now, it's part of the body, it's part of the document itself. And so the wording that's used implies a wide area coverage. It outlines what we need to do in the case of an event and the type of information that's going to be distributed. If we think about it from our point of view, it's a hardware specification. It tells us what the hardware must do. And there are some differences in some of the hardware, and so they have standards, and it must abide by the existing standards, as we said, the UL standards, and they have standards issued for mass notification products. And so it's looking at the features and the processes of the equipment. These standards then assure that the equipment will function and will be there when you need it. So looking at it from our point of view, it's what we need to build to meet the requirements going forward. What equipment we must supply in order to have a functional mass notification system. If we look at the scope, the document itself, if we look at this document, this is a page from the document, and the document is very comprehensive. It covers all kinds of details, 300 and some odd pages, so there's a lot of reading. But I found the interesting part here, the product used for, and it outlines what the product can be used for. So if we look at it, it's a standard intended to be used in combination with other appliances and devices to form an emergency communication and/or mass notification system. So in other words, it can link up with the fire panel. It can use the fire panel, take commands from the fire panel, and be able to provide a unified solution to provide a mass notification message. So we mentioned the other standards. In the code itself, it references a lot of other standards and references a lot of codes that we live by from day to day. The equipment standards, things that we need to adhere to when we're building appliances and devices. And of course, the National Building Code of Canada has to be abided by. So looking at the interfaces, what can it interface with? Well, we mentioned that it can interface and coordinate with the fire alarm system, and that's necessary. It must also provide a way of knowing that it is active, and it can alert the fire panel so you know that the mass notification system is functioning and it is active. And if the mass notification system is active, it can even override the fire signaling. That is good to know, because up till now that was not permissible. Can alert the operators for the interface of the fire alarm system. And if we look down the list there, the audio interface must be tested for total harmonic distortion, wiring, and monitoring. So there are a lot of standards goes into this that we have to pay attention to. A lot of things that we have to think about when we're designing and providing equipment to meet a mass notification system. And then, of course, specifications on how these things will work together, what fault messages are going to be sent, how those fault messages are responded to, and how they're detected. Even specifies things like power supplies and redundant power supplies. Failure of the power supply in the emergency notification system should not cause an artificial alarm, should not affect the fire alarm system, for example, to trigger. So there must be interface there that will work together. And when it transfers from the main power supply to a backup power supply, must do it in a proper sequence, and if you notice there, in a timely fashion. Transfer not to exceed 10 seconds. And of course, there are other standards as well that we need to take into consideration. High power speaker arrays can have their own power supply, and part of that power supply can be or can use a battery backup. And of course, there must be a way of verifying the charge in the batteries to make sure that they're available in the event of a power failure in the main power supply. Live voice and pre-recorded message communication can be on the system, and microphones need to be monitored. Now, it uses a term or an expression, there's no mix from microphones. Basically, if there's a mass notification message going out, and I have a paging microphone in my office, and I want to page someone in the warehouse, if there's a mass notification message going out, I cannot interfere with that. My message then would have a lower priority, and I could not mix my message in with the mass notification message. It can have automated and manual alarm signals. It can be all call or can be by zone. So you might want to just send an emergency message into one wing of the building, because that might be the only area that's under threat. It can be a manually generated alert, or it can take messages from others, and manually generated alerts would have the priority over the automated alerts. Manual paging would have priority over pre-recorded messages. Why is that important? Well, because when the responders come and they take command of the system, it's a live voice. So those manual paging from the responder's microphone then would have priority over the other messaging. It's required to have display information to indicate what is on and what is functioning. Needs to be a monitoring of the integrity. Any loss of emergency signal shall cause a trouble signal. For example, if someone cuts a speaker line or compromises a speaker line, there must be a fault signal that is sent that alerts you to that so the repairs can be made. And failure of the digital message while playing will automatically revert back to the alert tone. So if the fire alarm is going off and the message says we're investigating a situation in another part of the building, please stand by. If something happens to that digital message is played, it'll return back to the fire alarm tone. So we look at common performance and monitoring the integrity. Basically, any failure or any compromising of the system needs to be detected. It needs to send a message so that repairs can be made. Ground faults, for example, can cause failure in equipment, so that's not to be permitted and must be built in such a way that that is not going to cause a problem. And as we mentioned, signal breaks or ground faults will not cause an alarm signal. So if there is something, a catastrophic failure in the system, it's not going to set off the fire alarm system. Now, we mentioned sharing it with other equipment, and it can share control with other non-fire equipment. So you can have a third party monitoring this system, and it can monitor the fire alarm system too, and can control everything. But then that third party, any failure in its part, cannot interfere with the intent purpose of a mass notification system. The control equipment can be wide area, and it can deal with locations outside of the immediate vicinity. For example, if it's a school, for example, it can send a message back to the school board, or it can send it to other authorities that an event has taken place. So the high-power speaker array system. In Japan, during the tsunami, they found a lot of the cell towers were wiped out with the tsunami. The only thing that was effective was voice messaging over microphones and over PA systems. Well, TOA has put together and designed a high-power speaker array system, or a horn array, that has been effective in delivering sound up to 4 kilometers. And so it has been deployed in many areas where it's required in tsunami areas in Japan. It's even started to be deployed in other areas, even in Canada. And so this high-power speaker array system, and many like it, are addressed in the code. The dispersion output, how audible it must be, and even the battery standards that are used, and various other functions that are covered that must be met in the codes. So let's look at the product requirement review. We're looking at live paging, and we're looking at zoning capabilities. We're looking at pre-recorded message or digital message and zoning capabilities of that. Priorities. Fire alarm, of course, has the highest priority, and then that follows down the list of priorities. For mass notification system, the live voice of the responder have the priority, then live text-to-speech, auto response such as pre-recorded messages, and then of course, since it's a system that can be used for other than mass notification, can be used as a PA system, then non-emergency communication is the lowest priority. Must have speaker line monitoring so that if there's a fault, you know about it. The critical components must also be monitored so that if a part goes down, there's a message sent. Or if an amplifier fails in the system, there needs to be some redundancy to bring in another amplifier to take over the role of that. Alert signaling when it overrides the fire system, and also distinctive tones to be able to identify things that are going on. We mentioned the response times and recovery times that are specified in the code. Primary and redundant communication ports need to be there so that you can have message continue even if part of the system is compromised, and redundant power supplies or power backups. It's basically to provide a dedicated communication network to be used in the event of emergency. Where's it going to be used? And what's going to encompass it? Well, a lot of people are looking at these codes and trying to position themselves of how they are going to provide service. There are hardware manufacturers, there's software manufacturers, and there's services set up for building continuity, for life safety, etc. So when you look at it, it's going to be deployed either on the premise or it could be off the premise, but in the nature of being on demand. So it could be an in-building solution, could be a wide area solution, or it can be a solution that distributes messages to people on their personal devices. Many areas are going to require this going forward. As we said, the business continuity, disaster recovery, and being able to provide public alerts or warnings in business. And we think about commerce, education, the Defense Department, government agencies, hospitals, you name it, are going to be looking at these things as being required going forward. So what does the future hold for us in Canada? Well, it's a complex system that we're looking at, and the complexity of the communication will increase. Current codes of Canada dealing with mass notification have been released, so we know where we stand, what we need to expect. We know things like distributed messages, text pop-ups, and wide area or zone coverage, redundancy of the critical components, the alarm to be able to outline specific events. Needs to be survivability. We mentioned about redundancy, that's part of it. But even in some facilities, maybe it needs to be in a hardened location so that a local event is not going to compromise the system. And then there needs to be speech intelligibility and even coverage so that everyone can hear the message, understand the message, and know what the response needs to be. Looking at the matter of speech intelligibility, it's outlined as an appendix in this document, and it highlights some specific things that needs to be adequate, and we think about 15 dB over ambient, and that's standard in a lot of applications, but it also outlines some things like speech intelligibility. 15 dB over ambient could be just a noise, but you need to be able to understand the articulation to know what's being said. High-powered speaker arrays are covered, speaker line supervision. So a lot of these things are covered in the code and in many different sections of the code. So how does TOA meet the rising needs of this standard that has been released? Well, TOA has looked at what the requirements are and have started to be prepared quite a while ago of positioning our equipment to meet the standards. For example, our PC580 speaker is approved for mass notification. It's approved for fire signaling as well. Some of our other speakers have been approved with UL standards for quite a while now. And so we have moved to get others listed under the standard, our paging horns, so that we can use them going forward with these standards. And we have moved to certify some of our other existing products. In fact, we are the first company to have a pendant speaker certified under the mass notification standards. And it can be used for general purpose paging. And it comes in black and white, so it fits in with the environment. It's not an industrial looking application. So we've also developed products over the years that meets the requirements. We have our packet audio system, so we can have an event happening in one facility, can send the information to other facilities so that the message is received there as well. It can send live voice, it can send electronic signaling, and that can be done over the internet or over the wide area network. We have also our VM3000 system, which has been designed for mass notification, and is currently in the process of being certified, and that is very, very close. So we'll be the first company in Canada to have a certified product for mass notification. It's designed for multiple zones. Each box is capable of delivering 6 zones of messaging that can be paged into individually or can be grouped. And then every time you build up another box, it can address another 6 zones. So we can go up to 60 zones of paging for mass notification. We have paging devices, whether it's in a particular zone or whether it's to address zones. We also have the responders mics that can be used to be able to page into zones and take command of the system. We have also another system waiting in the wings, our SX2000, being created basically for larger scale facilities, for multi-building applications. Think about large shopping malls or maybe some office campuses, university application, for example, and it communicates over a wide area network. Now it uses CobraNet signaling between the boxes, and it allows for redundancy on that cable so that you always are assured of a signal going through. We also have other units that can be added, and if we think about how that SX2000 is built up, has a system manager and then audio inputs and audio outputs, and those audio inputs could be in one building, the audio outputs could be in another, or they could be in the same building. Also have control or contact closure inputs and outputs, and in a fully built out system, you could have over 1,400 contact closures to be able to send message, receive message, etc. We can interface some of our other equipment, such as our N8000 IP intercom system, in with the system to be able to send messages in from security, for example, and working to build things together. So in conclusion, we have looked at the NFPA 72 that was released in 2013, and we have also looked at ULC S576 released in 2014. and we see the specifications that are applied, sets guidelines for the minimum responses and minimum requirements that are designed going forward to create a mass notification system.